This session is about hydrogen waiting for big ticket projects. We have been listening, or players have been announcing pilot projects, but we are still waiting for large scale announcements to be made, or large scale projects announcements to be made on the green hydrogen part of it. So let me start with the first question to Amrit and Kiran. What is stopping big ticket projects to kick off in India with respect to green hydrogen, and what would be the impact of these big ticket projects on the overall hydrogen system if it is being announced in 2024?
Hello. Yeah, that's a tough question. So I think we are all in anticipation of the big ticket projects in India. On one side is that. The other side is that we have this India National Green Hydrogen Mission that was announced last year. And I mean, I'm very, on one side, very happy to say that the mission is going as defined. Every bullet point is trying to be implemented in a very systematic manner. However, obviously, we are, as we all know from the question itself, that things are not moving as fast as we expect. And that is mainly because of who will take the first step. And the draft NHGM had a demand mandate, which did not come in the final actual mission which was published. That is one of the reasons I would say I will attribute to lack of large big projects. But I will not stop there, because a lot of green shoots are being seen post the elections. Now we had seen a major green ammonia procurement project announced by SECI, so which is a great development. So we will definitely see big ticket announcements based on that tender. The previous hydrogen production tender, tranche 1 and now the tranche 2, both are announced. And they should lead to about 3 to 5 gigawatt electrolyzer capacity if they all fructify. But only thing is, these are incentives based on production at a much later stage. I think the developers are doing their homework. And as is the case globally, what we have seen as an OEM is, if there are 100 projects announced, we hardly saw about 7% reaching FID in last year. Now the number is slowly growing to 10%. So there is some growth. I think India is a little lagging on that, but I'm sure we will catch up fast. But there are certain parameters that need to really work out for the big ticket projects to materialize and actually get implemented. Yeah, I think we'll discuss this in further detail. I'll ask Amrit to comment.
Thanks, Kiran. I'm just mindful that we have a room full of people who've done large projects, in the chemical industry, allied industries. The principles don't change. Why haven't large projects taken off? It's because of scale. It's because of lack of a customer willing to offtake. Right? It's as simple as that. And then, of course, the price. The price discovery is probably happening as we speak, with the hidden tender on ammonia out. The results were out just yesterday. So that's one market signaling on price for green ammonia. The SECI tender for fertilizer will be another market signal that hopefully should get concluded in the next 2.5 months. But the fundamental problem is long-term offtake agreements, and it's actually a problem which can very easily be solved if there is intent, and I think the government has indicated there is intent from the fertilizer industry. We just have to replicate that in the refineries, and then steel, and then you have a market that's built very quickly so that FID stage decisions can be taken about scale and project development. That's as simple as it gets.
Yeah. Let me answer the second part of the question, which is what will large-scale projects do to the industry? They will bring down the cost significantly. It will help actually prove what is in theory on the ground, right? And there are many pilots, small scale, medium scale, lot of things are happening. But I think the real large scale, like 100 megawatt plus kind of thing, will change the game. That one, it is no more a theory, it is actually possible. So we have done a 45 megawatt PEM electrolyzer based hydrogen production plant in Georgia. So that gave us a lot of confidence that yeah, large scale, new technology can be set up and expanded. Right? Similar things in India would mean that the ecosystem will fully develop. Everyone will understand the risks properly. So that means the pricing variation will come down and the learnings will be applied to the next project. So first project versus next project will see significant cost reduction on those aspects. The soft cost particularly, because soft cost is where the uncertainty is very, very high. The technology, there is a number, there is a supplier, there is a contract and all, but the soft cost is where all the concerns are. I think they will be taken care, and then the incremental cost or the marginal cost of the next project will go down significantly. So from a people perspective, from an ecosystem perspective, from an experience perspective, licensing perspective, there are many, many things that the initial big ticket projects will be taken care of. So we have to really, really be supportive from all perspectives and ensure that these projects are successful. And the learning is the biggest takeaway, not just the project. So project we should see as a byproduct, but the learning as a main product from the initial big ticket projects. Yeah.
So what is stopping? Is it the technology or is it the investment?
No, it's not the technology nor the investment, because investors will invest wherever there is a credible project. So therefore, it's not a problem from investment. In fact, if you ask, there will be so many people ready to invest into hydrogen. So investment is not a problem, right? Technology, China has gone ahead with implementation and they have advanced the alkaline technology to a great extent, right? PEM technology, we bought a technology company 3 years back now, and that we have scaled up and did a 45 megawatt and executing a 100 megawatt project. So technology is scaling, PEM technology is scaling very, very well. So technology is not a problem, investment is not a problem. But the main challenge is the demand. Demand right now, industry is waiting in anticipation, right? Industry wants to do, industry is ready to do, industry sees this as an opportunity and also a challenge. But I think somewhere the onus lies on the government to decide clearly and with a clear path that okay, hydrogen is necessary for decarbonization and it has a definitive role to play. Therefore, certain amount of energy requirement, we have to see how we can meet through hydrogen. That commitment from a demand mandate perspective or a decarbonization perspective, either carbon emissions or a specific mandate, either of them will drive adoption immediately in a big manner, right? There was a lot of anticipation of exports, right? Within a country, you have limited parameters to handle, but when it comes to export, there are more parameters to handle. It becomes more complex, right? So we had to kind of find a balance between attractiveness and feasibility and look at domestic projects first or export projects first, right? Either way, if one project happens, it will definitely support the next project. If export happens first, the domestic project cost will be down and then you can actually do a lot of market. If a domestic project comes, that experience will help become internationally competitive, and that means India can actually win market share. So it's that's there, it's stuck.
Or are we waiting for solar cells to pick up, get renewable energy at a lower cost, then only things will move, or?
I mean, see, that is not going to happen, right? Because if you wait, every day we wait, we are incurring cost. So this is something that needs to be really, really put forward with a proper number. Maybe we should have a dashboard saying that every day you delay, this is what we are adding cost in terms of the sustainability and climate change losses, right? So it is not so much about that, because both will have to evolve, co-evolve. In fact, solar industry will not grow significantly unless hydrogen takes off, because grid can only absorb so much without any other support technologies. Long duration energy storage is critical for solar and wind to pick up. So therefore you need hydrogen, you need battery technology, you need any other technologies in order for solar and wind to grow and increase their penetration beyond the limited penetration that we are seeing now, right? So that means they will achieve scale. So what we are doing, like 10, 20 gigawatt to 50, 100 gigawatt, the scale will bring down the prices. So both will go hand in hand. So we cannot wait for one to happen for the other to happen.
So I think the fundamentals are very clear with the way our speaker Kiran Kumar Alla talked about. Amrit, do you wanted to add something?
Yes, I just want to add, as Kiran said, the hard questions are already answered, are in place. It's really a soft question about a leadership decision. Because if refineries, and it's also how we look at the ecosystem and decisions are taken. If we say business as usual, every entity thinks about how they're going to make this profitable from day one, it's not going to happen. So if refineries together decide we will replicate what's being done in fertilizer, then you will have market creation faster. Project development can proceed further because then a large capex can be put in place for multiple offtakes. Fertilizer, refinery together, or maybe steel plant together with that. So as you see, they are connected, they're not disconnected. If we think of planning this from a business as usual, we'll do it in series and a sequence, it'll be 30 years and we will be still here. So let's understand that the world is also evolving fast, and if we don't move fast enough, these plants will probably be in Malaysia or somewhere else, and we will still be doing, a discussion about large projects.
Thanks, Amrit. We have seen a lot of announcements on the PLI and both on National Green Hydrogen Mission and the PLI scheme for green hydrogen production. We have also seen the vendors being finalized for a lot of projects on the government side. So government is taking all the right initiatives which the industry has asked them to take. So my concern is government is taking initiatives. Big ticket projects are still not happening. Are we waiting for these tenders to be operational? And once they are operational, then only things will move? Pranav, your thoughts on this? Because you are also planning to set up your own factory. Plus, you are also an EPC. So you want to gain first-hand experience before planning to set up for other companies.
Thank you for asking this question. We actually have done. Oh, sorry. Am I on? Yeah. We have actually done this. So we commissioned our own demo unit with a bought-out electrolyzer 2 years ago, around August, September 22. We commissioned our own demo. We gained first-hand experience, and then we decided to invest in this enterprise as a manufacturer. We've gone and done a technology partnership with McPhy, France. We are, as we speak, assembling and manufacturing electrolyzer stacks in our Hazira facility. We've been granted PLI with a capacity of 300 megawatt per annum. And as things go, we seem to be in a good position to meet that this financial year. Now, that's what we as L&T are doing. Now, to answer your question that, big ticket projects are not yet coming, what are we waiting for? I'll just draw on what the other speakers just said. And also in the previous session, we heard one speaker mention about who will pay for it, right? So, hydrogen is not new. Electrolysis is not new. Here we are not talking of something which is path-breaking, like, AI, which nobody has heard of and it is coming up new in the world. We are talking of a molecule that is known, we are talking of a technology that is very well known in other industries. It is only that electrolysis was not much talked about in the hydrocarbon sector or in the refinery sector because the other technologies which were gas-based, crude-based had achieved much, much higher efficiencies. That is why we had not talked about electrolysis in this sector for a very long time. The chemical industry has been doing electrolysis since many years now. It's nothing new. The question is, now that I am saying I want to produce electrolysis, I want to produce hydrogen using electrolysis, that electrolysis will work on renewable power. It has a cost to it. That cost has to go in the final product. It cannot go anywhere else. Whatever chemical you make out of it, whether it is a fertilizer, whether it is any product coming out of a refinery, that cost will pass on to that. Are we as a country, as a people, willing to bear those costs? When talk comes of sustainability, the first geographical area that instantly comes to mind is Europe. Why does that come to mind? Because they are now, as a society, willing to bear those costs. So I think this may sound a bit more philosophical side, but we need to answer this question ourselves. Tomorrow, if I go in the, in an online marketplace or in an offline marketplace, and I see two products, same quality, one from a renewable source, other from not, and the one coming from a renewable energy source is 10% higher priced, will I pay for that? I think that will answer the underlying question that why are big ticket projects not coming? And this is our opinion.
And how do you see the EPC market? Because you are also the one who would be constructing or installing or commissioning these projects. So, one as a user or one as a manufacturer of hydrogen, green hydrogen, and the other, the hat that you are wearing is of the EPC. So, your thoughts on that?
We are also wearing a third hat of a developer.
Okay.
We are also looking to develop projects ourselves, especially in the green ammonia space. So a lot of thinking is going in that direction. But yes, to answer your question regarding the EPC market, the size is critical. Again, that brings us to the agenda of this discussion itself, that big ticket. If it really happens that big ticket projects come up, I don't see a challenge in the EPC market picking up per se, because people are waiting for it. The question is if big ticket projects don't come up, or if the companies who want to set up these plants decide to go not on the EPC route but on the EPCM route. See, players are available in all. In EPC, there are very good companies in this country. In EPCM, there are even more number of companies in this country, in the EPCM route. I don't think the constraint is on the execution side. The execution can be done. Rather, since we have a lot of experience executing conventional hydrogen plants, whether say naphtha-based or natural gas-based, we would say executing a electrolyzer-based green hydrogen unit is quite simpler. Much more simpler than what we do in a conventional hydrogen generation unit. So execution may not be as much of a challenge as it would be the investment decision itself. That is what is our take on this.
Thanks, Pranav. Now I come to Anil Srikar, Pavuluri. And their focus has been Indian Railways project.
Yeah, of course.
So I think all the audience would like to know, there have been a lot of stories on net which talks about that the tender will be floated. Yeah. We haven't seen a big tender from Indian Railways. You are very glued to Indian Railways. So if you can give us an update on that part and how these projects or how Indian Railways projects are getting impacted with whatever little that the government has done, or do you see it has hastened the process, or the process has slowed down?
Yeah. See, if you see in the Indian market right now, Indian Railways is the entity which is the first one to have floated a hydrogen-based mobility tender in the market. And it was launched, I think, in 2021 or 22. There was a competitive bidding. Initially, they thought that we will power the train. It is actually a diesel locomotive which has to be retrofitted into a hydrogen locomotive. It's around a 10-coach train, 210 meters long. And this initiative is part of a hydrogen as a heritage. There were around 35 trains which are being planned by the railways, and out of which this is the pilot project which they wanted to do. And the train will operate from Jind to Sonipat. It will travel at around 400 kilometers up and down twice, and we are actually setting up as a GreenH, we are setting up the hydrogen refilling station for the particular project. So this started in 2022. Initially, there was no electrolyzer involved in this. They only wanted to do with the getting hydrogen somewhere, filling it up and supplying it to the train. Then they thought we have to go green into this, because ultimately this project is going to go, hydrogen for heritage is nothing but a concept of green hydrogen. So there was a lot of delay from Indian Railways, in the sense that nobody knows how to do this. I mean, there are some companies, overseas companies, who have bid for this, and fortunately an Hyderabad-based company has won this contract. So they started building that train, and first of all, this is a very ambitious project. In all over the world, if you see, it's only a 3-course train, 300 kilowatt train. Now this one is a 2.4 megawatt. And this is India's first hydrogen train, 10-course train, and the longest train in the world. If this gets commissioned, the whole world will see India. So what is it's doing in mobility, especially in the railway side? That is what we are waiting for. So the project has a lot of complexities. As I told you, from the train side, these are the complexities. And from the refilling side, we are employing a 1 megawatt PEM electrolyzer, which gives around 430 kgs of hydrogen a day and a 500 bar compressor. And then comes the real complexity, that is the storage. We have to employ around 3000 kgs of storage, high pressure storage of hydrogen. Hydrogen, of course, it's a very light molecule. We don't have, first of all, standards for storage. That's the most important thing. Whatever we have right now is static mobile pressure vessel. That is SMPV rules. That is only for, the 40 bar low pressure storage in some tall cylinders. And it was in the refineries or fertilizers and all. Now we have an on-ground 3000 kg of storage. I need to store it at a very high pressures. So what we have done, we have split it in 2 parts. One is a 200 bar storage, which is around 2300 kgs, and 500 bar storage of 700 kgs. So why I have split it up? Because 200 bar I'm storing in steel cylinders, and that is approved by PESO. So I can get the approval of PESO easily. But 500 bar is where I'm having the problem. There are no cylinders being approved by PESO 500 bar and type 4 cylinders. And why type 4? Because those are the cylinders which we need to use for continuous refilling purpose. Type 4 is being used in the vehicle as well as the on-ground storage. I don't have the approval for that. So where are the standards? So thankfully, recently, I think 3-4 months back, I think last year as well, there was a draft GCR rules which are being released, gas cylinder rules, under which there was a mention of a lot of overseas standards, EN standards. MNRE has come into the picture, they are going to support us. So there are some exceptions also in that. So considering all those aspects, we have approached PESO and we are trying for the approval of the cylinders. So this whole project is going to take off only when we have the approval from PESO. I didn't even start my site activities. I cannot start without PESO approval. So he has to approve the cylinder, the layout, then only I can start. The train is under process. It is being made in Chennai. It's going to come here maybe in September, October. I have to produce hydrogen and I have to commission the project by October, November. Provided I have the PESO approval on time. And on this basis, success of this basis, the railways is going to float many other tenders in the market. And this happens to be the most ambitious project in the mobility side. I can say not only maritime, on ships and all, it's in railways or buses. This is a 420 kg dispensing I have to do in 1 hour. That is a challenge, and the train has to run. So I will be supplying the hydrogen, and the company, Hyderabad-based company, is doing the train. So hopefully we get it commissioned within time.
So PESO is stopping you from...
No, PESO, I cannot blame PESO. PESO is not aware of the standards. I mean, we are all...
Do you see PESO approving the standards in 2024?
Of course, that is where all the other ministries, the Ministry of MNRE and all these ministries are helping us out. They are framing standards, especially for storage, replicating whatever we have in overseas markets, EN standards and all, NFPA standards. And PESO is actually going through those. And these DCR rules are being framed, are going to be framed as per those standards only. We cannot frame our own. We are going to follow those standards, and that will actually accelerate the process. If you see, this is the storage I'm talking about in our project. These all mega big ticket projects, why are they not taking off? That is one of the reasons is the standards are not available.
Once the PESO approves, then there are no other roadblocks?
There are some other roadblocks. Roadblocks are there everywhere. I mean, see, I told you, this is the first tender which came out, why hasn't been commissioned till late? I mean, there were many roadblocks in this. Safety is the main aspect, and storage comes as a priority in that. We need to have the standards ready, and people will make as per the standards. Whether it will run or not, I think we have to see some pilot. That is the reason we are doing pilot projects.
So we have Dr. Selvaraj from CSIR NCL, and he has been doing a lot of work on the hydrogen along with Mr. Professor Lele. So, sir, the focus, as he rightly talked about, cylinders, Type 4 cylinders, is not being approved with whatever standards that he's talking about. So it is about storage, it is about compression technologies, it is about transportation, and then finally the utilization part of it. As a CSIR, NCL, and as a researcher focusing on R&D, how do you see the way forward with respect to these 3-4 items that I talked about?
Thank you, Mr. Pravin, for this wonderful exercise that we all should do. So as he rightly said that the whole thing, what is looking like a real bottleneck is the fundamental idea of the R&D skills that India is lacking right now. So that's where I think the point what Mr. Pravin was talking about, that what is our R&D activity, that is where exactly CSIR comes in play. We all address most of this, the problems that is being discussed. For example, CMARI's lab, CSIR lab, making Type 4 cylinders, which are currently under testing. So almost the testing should be completed soon. That is one example. What it was very, very, very relevant to what he was talking about. So if you have this kind of activities gearing up faster, that should probably kick off the big ticket projects much more easier. But the problem here is that the speed at which the R&D has to go, and then there is a lacuna there. I can just say, for example, the first layout of the National Hydrogen Mission layout of 19,744 crores. So it's about 400 crores were kept for the R&D, which is about 2%, which is actually very, very low if you really want to become self-reliant. That's a serious lacuna. We can get technologies imported, for example, a lot of EPC activities our co-panelists were talking about. So these all can come, but finally when it is running in the field, the service part of it, or the immediate action that we need to take, the local skill set should be ready. The local supply chain has to be ready. So these are the real bottleneck. Probably the big ticket programs are getting slowed down right now. So in my opinion, I think R&D funding and R&D activity should be accelerated to help this to go faster. Let's take an example of electrolyzer. For example, PEM is coming in, and then PEM is expensive. Alkaline has its own problem. There are futuristic technologies like anion exchange membrane technologies. So these are really probably very apt for a kind of an India kind of landscape where we have the self-reliance on the core technology, which is free from platinum group metals, the corrosive, the corrosive environment, and the electrolyzer technology itself gives us the opportunity to use less corrosive, the MOC. So these all will bring down the capex. So when the capex comes down, I think the investment becomes much easier. And these are little bit more futuristic, but these are something that I think Government of India should accelerate. For all these things, we need R&D funding. R&D funding becomes a crucial part which will help this. Storage, as I told us, the cylinders are being developed and people are looking at solid state storages. There are some programs in CSIR coming up in a big way that the solid state storage, the global benchmarks, we are able to match. But the question comes is that, who will make it at a mass scale and then convert it? So these are again a lot of R&D which needs to be worked. Sensors, leak detectors, these are a lot of R&D based skill set that we have to evolve. The last part is that basically the skilling. Even a common man at a fueling station who will be just filling the hydrogen, how much he should be aware of how to handle this animal. Hydrogen is a completely different animal. It's not the fossil fuel gases that we handle. In our labs, for example, when you do the piping, we do a leak test with helium because that's closest to the hydrogen. So we do a leak test, but then the moment it passes helium leak test, we move to hydrogen, it fails. Just one atomic number difference between hydrogen and helium. Helium is double the size, but this small difference makes the whole platform of how do you want to make the piping, sealants, the fittings. These are all something that one need to understand. So that local supply chain and the manufacturability, if it has to evolve in India, the R&D is the only way. So I think there is a lot of demand that is needed for R&D funding, and probably that will push this big ticket program with a lot of confidence and the supply chain assurance from the local ecosystem.
So will this come from MNRE or will this come from DST?
This right now, MNRE is the line ministry, so DST and CSIR are basically the execution body. So mostly CSIR is taking right now the biggest role. But DST is also with us. But what DST does is basically DST is not a research organization, so basically they fund it. The large part of R&D activities happens in CSIR labs and other universities and IITs and so forth.
Thank you, sir. We have been, we have seen a lot of announcements on hydrogen hubs, and every state say that they are making hubs, whether it is Kerala, whether it is Odisha, even the ports are saying that they would be having hydrogen hubs within their port, and a lot of announcements have been made in this regard. Amrit, my question to you, as you are chairing a group of hydrogen companies, and you work with almost all of them, which are large companies, and these large projects will be only be driven by these large companies. So how do you see these hubs being structured, planned, and executed? Do we have project developers? We have some of them out here in the room, because they are also thinking of creating hydrogen hubs, so that the entire ecosystem benefits more from a futuristic perspective. So are these project developers ready to build up and operate hydrogen hubs, whether on a partnership model or whether on a just a public model? It depends upon how do you plan to move ahead. And what should be the role of the government and the industry in these hubs? Because everybody is talking, but I don't see on the ground something happening. Kochi has been saying that we would be doing, even the Chief Secretary is talking about it. So if you can demystify these things, because these questions are not being answered, I'm not getting the right answers. So if you can demystify for the delegate.
Yes, sure. And it's a tough task to get hubs right. But for the benefit of the room, those who may not be aware, I also represent India Hydrogen Alliance that Pravin spoke about. India Hydrogen Alliance is backed by Reliance, Aramco, Sumitomo, Torrent Power, and a whole lot of other players as well, both on the equipment side, potential off-takers, as well as investors like the European Investment Bank. So, and one of the early pieces of work that we did was to say, what can we learn from Europe? Europe has hydrogen valleys. Can we create similar valleys in India? Hubs. And that was the idea with which we went to MNRE. That was included in the Green Hydrogen Mission document. We started working with Kerala, proposed the Kochi hub, essentially replicating a Hamburg hub model, a port-linked hub where there's production and consumption co-located at one place, as an offtake co-located with production, but offtake de-risked by 2 or 3 use cases. So if you take Kochi as an example, and you can do the same thing with Vizag, you can do the same thing in Tuticorin, or you can do it in Gujarat, You need an industrial off-taker, so either a refinery, steel plant, fertilizer plant, one of these three, right, the large off-takers. And then from a volume standpoint, maybe some transport off-take, heavy duty from a state transport department. And you have a hub. I mean, in theory, that's as simple as it gets. The beauty of a Kochi sort of location is there is a BPCL plant, there is a FACT fertilizer plant, both government owned, and there's the state transport department. The government can overnight create the hub, run it, de-risk it with offtake from government enterprises. You could do the same thing in a private hub, or you could de-risk it between public and private as well. So in a Toothukudi, theoretically, you could get SPIC to come in, look at fertilizer, some cement clusters, etc. to de-risk it. I think this is, going back to Kiran's point about soft elements of this planning are very important because this is not new. Europe has done this 10 years back. So, but yes, collaborating in this manner, different use cases together is something new for us as industrial planners or structuring it, This is par for the course in Japan, Korea, Europe.
So is it a mindset challenge or?
It's definitely a planning challenge and a design challenge. I'll make the point that I made earlier, right? Currently, individual enterprises are undertaking hydrogen projects, massive risk that they are taking on their own. When we looked at large projects, we went straight to exports. We didn't even go to 100 megawatts, we went to gigawatt. So either it is pilot scale or it is gigawatt. Now, that is where I think we need to correct and go back to, again, I'm giving the example of Kochi, it doesn't have to be Kochi. 100, 150 megawatt electrolyzer capacity in phase 1. Can we find offtake for that? Will BPCL, FACT, or State Transport Department be able to offtake it? And then maybe, if they can't, then you balance it out by exporting it. Is there a buyer for the export piece? I think for a long time, for almost 2 years, we've been getting mixed signals. It has to be either export hub, or it has to be pilot scale because there's no demand locally. And you've heard from people in the room over the last 2 days, that's nonsense. There is demand domestically, there is demand internationally. It is about price. It's a commercial conversation. Why should we get into deciding what should it be? Only a project developer should take that call. L&T here, or whoever's developing that project should take that call. What should be the technology? What should be the use cases? I mean, actually, they shouldn't even decide use cases. Whoever takes the offtake should decide that. But whether it is export, domestic, it doesn't matter. So I think there's definitely a challenge there in terms of understanding how you scale this up. And yes, we could do, let's say, 100 small hydrogen pilots, everybody learning expensive lessons in India, or you could do 5 large hubs. Now, again, let's go back to Europe. What they have said is, we are taking the hub or hydrogen valley route, and they will be demarcated projects of EU-wide importance. So you give them the same status like your, let's say, high-speed rail project, the bullet train project has, right? The hubs have to be protected and granted special privileges and tax treatments because they are national projects. I think that is where I think we are still looking for more support from the government, but the industry has a big role to play.
We haven't got that national project status for hydrogen.
Not for project hubs, as in hubs yet. The only hub which is probably close is the Kochi project, which has got now a techno-commercial study done by GIZ. The report should be out and the tender should be floated. On the private sector side, there are a few attempts and some will be captive, probably in Gujarat. Some will be maybe not captive, but have a mix of export and domestic use case on the East Coast. But anybody taking public money, as a matter of principle, right? Anybody taking public money on any of these hubs or large projects should make that learning available to everybody else in the ecosystem. That's the only way we will mature as a hydrogen, on the hydrogen transition.
Kiran,
I think excellent points, Amrit. I think from a national importance perspective, we should think of these initial projects or hubs as a foundation. We want to build a 1,000-floor high riser, but initially you need to go down, right? So this is like going down into deep into it and then laying the right foundation. And then the public learning is also a very important aspect. See, Plug as a company was doing many small things earlier. They found one particular application of forklift trucks, removing the batteries, putting a fuel cell using hydrogen, right? Today we have 60,000 plus fuel cells operating on hydrogen. And there are more than 50,000 refueling operations on a daily basis. And these are being done by the operator himself, right? And there are so many refueling stations. And these are all distributed. And all this actually happened in a way because we took the risk, as you said, massive risk in terms of buying the liquid hydrogen, storing it, regasifying it, refueling it, and also repairing the fuel cells. Now we are seeing the hub impact in the sense that when customer is saying, oh, I have hydrogen, now can I use it for some other application? We have seen customers using hydrogen fueled fuel cell to charge electric vehicles because the grid is not available. So that is the advantage of hub. Once the platform is available, then many innovative applications will come into picture because now there is no major cost, there is only marginal cost. So you can take advantage of what is available. So that is the reason hubs are very critical. I think US has put a major onus on hubs. Right, we have small valleys, but I think we hope that they will grow with a little bit of more private involvement into them and then make them bigger and then take the benefit of the collective learning. And that also brings another important point of people development. The more people are available in the ecosystem, the faster the development will be and the lower the cost will be. Because you will not be doing errors, you will be doing things much faster. Yeah, thank you.
In this case, you need a collaborative model. And unless and until everybody sinks in their part of the cost, you cannot have a hub.
Yeah, sometimes it is not the cost. Sometimes it is experience, expertise, time, right? So it's not just cost. See, that's where...
At least our aim should be to make one hub ready.
Yeah, absolutely.
And then replicate.
Yeah. I mean, not only replicate, also diversify, right? So, take some portions, right? Do different things based on the geographical requirement, right? That is how the innovation happens. And the more applications, practical applications, on-road applications we do, the more ahead we can be. Right? Instead of waiting for technology to evolve and then bring it to India, we can actually drive it from here.
We can have 3 hubs, one for fertilizer, one for, say, steel, third for refineries, and so we gain that experience and then export it to other countries.
Yeah, no, we shouldn't say these are not happening. These are happening. They're all happening in isolation. I think this synergy and bringing everything onto a project mode rather than a ministry mode, I think would actually make a lot of difference and a lot of synergy. That's the only point.
There are a lot of topics to be discussed, but I thought my main concern was to awake you all through these panel discussions. And if you have any questions, please raise your hand. Be short and precise. I would request volunteers to take the mic from here, cordless. Short questions, sir. No comments. You can take those comments during lunch break.
Good afternoon, everyone. Thank you for the insightful session. My name is Nikunj Garg. I am from Payal Industrial Park in Dahej. And we have invested into a green hydrogen company named Fourier Inc. Of US, and for providing green hydrogen to the chemical companies coming in our industrial park. And as per our research, we have come into the conclusion that either we can reduce the cost of the electrolyzers or the renewable energy. And several companies are working on the R&D initiatives, like SEID Norway is working on cold methane pyrolysis. And the World Bank is working on making 100% renewable energy power plants. So what are the R&D initiatives taken by you guys? You have been working in this industry for a very long time. You are industry veterans. So what are the initiatives taken by the Indian companies towards reducing the costs?
I mean, I wouldn't say on the Indian company, but I'll tell about the research part. The precious group metals concerned about PEM is, I would say, is overblown, because we have a clear pathway of reducing it significantly and exponentially in the coming years. The more megawatts are installed, the more the PGM will go down. That means that same metal can be used to produce much more megawatts. So that is one definite thing that is happening, right? And there are multiple pathways to hydrogen. We cannot ignore any pathway, but at the same time, it's a question of scale. What is the technology that can scale easier, faster, and across? At the same time, we should not ignore other pathways. So that is, both are happening, and I'm sure Indian companies are doing many things. I would request my colleague Pranav to talk on that.
Thank you, Kiran. Yes, we are working. What we are working on is primarily indigenization, in the sense that we have a collaboration with IIT Bombay right now, and we have actually set up a lab within IIT Bombay premises. We are having a few people from our organization. We've recruited a few more researchers, PhD scholars who've just completed their PhD in this sector. And the idea is to have an indigenized version of a PEM electrolyzer. So, like, you might say this is a bit, more on the first principles research side.
Sort of a plug and play model to be pushed in a company sector.
I would not say that. See, electrolyzer itself, if you see, it is plug and play, as opposed to a conventional hydrogen generation unit, which you have to commission elaborately over time. You have to maintain a certain operating, capacity. Electrolyzer offers you much more flexibility and those kinds of aspects. So, what I am trying to say is that the research is more on the indigenization aspect, as Kiran mentioned. The research is more on, trying to go to less expensive metals in the stack itself, and work is in progress. That is what I will say, definitely.
Any question from this side?
Thank you.
Ranjit? Why is it that all
Hello.
industrial parks are more interested in
My question is rather theoretical per se. So, if you look at India broadly, we do consume 36 million tons of urea, of which 10 million tons is imported, and which would require theoretically 1 million tons of hydrogen, and which raw material is natural gas. And this is a subsidized business. Government of India has subsidized it heavily. So, I mean, can this be explored? Because there's already government subsidy in this part, and if green hydrogen can be produced at a cost lower than the natural gas, I mean, with the going Russia-Ukraine scenario and uncertainty of the gas prices, so this is also an opportunity. So is the green hydrogen, the sector working on this front, and can you enlighten on this?
Pranav, your views, you have been...
This is already in the consideration of ministry. But the only thing I would say is it should not be conditional to that green hydrogen being cheaper than natural gas. That is will not happen in the short run. So therefore, the government has identified this as a priority area. They said we will identify it as one potential area of green hydrogen application. So the first fertilizer tender is for ammonia. I think once that is successful, I think attention will go to this area. Yeah, it is under consideration by MNRE.
I will add one more point here, and it is a more basic level than just cost. Urea needs ammonia and CO2. Natural gas, naphtha, these are hydrocarbon-based plants, give you both. You get to produce hydrogen. As a byproduct of the hydrogen generation, you also get to produce CO2, and both of them you use to manufacture urea. There is a stoichiometric balance. So it is well known in the industry that ammonia, urea plants are one of the most energy efficient plants across the chemical industry. Now when we talk about having green hydrogen into the picture, we are cutting off the CO2 aspect, right? Because we are making hydrogen from water, there is no carbon molecule involved. So where you get the carbon from? Then the question will come, okay, I can get carbon from maybe biogenic sources. I can get carbon from maybe industrial flue gases capturing it, but then there is a cost to capture involved. So it is not about just getting the cost of green hydrogen comparable to natural gas based hydrogen. It is also the economics of CO2 which comes into play. And when we talk of fertilizer plants, we cannot talk of small scale. It has to be large, and by large scale I mean 2,500 tons per day of urea, 3,000 tons per day of urea, 4,000 tons per day of urea. At those volumes, getting CO2 is what is one of the main challenges right now, why it is not taking up a speed of development which it should. This is the capacity is the challenge.
So let me end here.
Sir,
there is a
1 minute, one question, sir. Sir, government has floated for hydrogen testing facilities. As all respective panels are from hydrogen is there, it will be good if you elaborate on that point. How we can get that facilities, or we can be a part of that.
This is a very, very important point which normally gets skipped in most of the discussions. One thing we should remember is that we try to abate a CO2 and then try to get a hydrogen and a replacement of that. If you look at the global warming potential of CO2 and then the hydrogen, okay, hydrogen has 5.8 times more global warming potential than CO2. Okay, so why I'm referring this is that when we are thinking of gigawatt factories of electrolyzer manufacturing here, and a lot of R&D is being planned, we are going to vent a lot of hydrogen into the atmosphere. It will go to tons of hydrogen per day we will be releasing into the atmosphere. You see the effect of that. There is one lab in Fraunhofer in Europe, along with Fraunhofer, they built a lab called Luna Laboratory. It is a model lab for testing facility. So they have systematically gone through every aspect of it. For example, when you make a electrolyzer, in the R&D level or the testing level, the hydrogen purity is never assured 100%. It cannot be 100%. It will be a mixture always. So the off-taker would be having a required criteria to use that, otherwise he rejects it, and every batch or every day is not going to be the same. So there is a separation cost, there is a compression cost, all this. So no one wants to take this, so it will be simply vented. Right now there are only two venting fashion available. One is called a cold vent, which is directly vented into the atmosphere. The other one is called the flaring. Fossil people do that. So during flaring, again you mix some of the fossil fuel along with that, so you co-emit anyway CO2 in that. And cold vent has to be neutralized with nitrogen, otherwise the concentration is too heavy. So around 24 times more hydrogen is needed to dilute the hydrogen before it goes to the chimney. So these are something nobody talks. So we need to build hydrogen testing labs in India if you want to really do a lot of self-reliant production, or what are the targets we keep. So these are not, as of now, these are not available. At lab scale we do something, but that's not enough. So if you want to really build gigawatt factories, these are some of the problems we have to address first.